It's been a busy week here at the Blanco Lirio Global Headquarters. It's now Friday, the 28th of October, and yesterday, Latam Airlines Airbus A320-200 encountered a severe thunderstorm while on approach to landing to Asunción's airport, resulting in a bit of aircraft damage. So let's get into it, check it out, and clear up some common misconceptions about this level of damage on these aircraft. Starting with Simon Radecki's Aviation Herald. A Latam Airways A320-200 performing flight as LA-1325 departed October 26, 2022 from Santiago, Chile to Asunción, Paraguay, with 48 people on board. Was on approach to Asunción's runway 20 when the crew initiated a go-around from about 2,400 feet MSL, mean sea level, due to weather. The aircraft then diverted to Foz do Iguaçu, if I'm saying that correctly, Brazil, for a safe landing on runway 33 about 40 minutes after the go-around. The aircraft remained on the ground at Foz do Iguaçu for about 3 hours and 20 minutes, then departed runway 15 to Asunción again. On approach to Asunción's runway 20, the aircraft flew through a thunderstorm and received damage to its radome, but continued for landing on Asunción's runway 20 about 5 hours after the initial go-around. There were no injuries. The airline reported the aircraft encountered severe weather on its flight path and performed an emergency landing in Asunción. Passengers and crew disembarked in good condition. First, let's look at Flight Radar 24. Here's the first flight from Santiago to Asunción with the go-around. They get into Asunción about 9 p.m. Universal Time, or 2100 hours Zulu time. We'll use that to take a look at the weather, the METAR. And they get down to about 2,500 feet MSL and then initiate the go-around. Now let's look at the METAR, the weather at the time that they did the go-around. Here at Asunción at 21Z, it's showing the winds at 200 at 26, gust 40 knots with heavy rain and thunderstorms in the area. Good choice to go around and divert and wait this weather out. The weather at their divert station at 22Z, wind 02 at 7 knots and a few clouds at 2,000. Good weather over there. Now when they come back for the final landing at Asunción about 2Z, the weather has improved. The winds have died down, 050 at 9 knots. There's still thunderstorms in the area. Now let's take a look at the Flight Radar 24 data for the return flight to Asunción. The crew, I'm sure, has taken on fuel for this flight, and they are flying a very indirect route because I'm sure they're attempting to get around a line of weather that's located out here. Unfortunately, we don't have that weather radar display to overlay on this display here. Now it looks like things are going well with the autopilot on as they make their trip around the thunderstorm. They find a location where they can get around this thunderstorm and begin their left turn towards their destination at about 24,000 feet and 380 knots ground speed. Remember, that's ground speed that's shown in yellow down here and altitude in blue. Then with the autopilot on, they start getting into some severe turbulence. Look at this vertical speed, 2,300 feet per minute, trying to maintain an altitude of 24,000 feet. Now let's go back and look at some of these data points one at a time, paying attention to the vertical speed here. Minus 384, minus 1,500, plus 1,000. There's that 2,300 positive feet per minute. Rate of climb, 1,600, minus 700. At this point, there's minus 1,400. Wow, what was that? There was a, look at that, minus 4,000. Where is that? Minus 4,000 feet per minute for just a moment there. Right in here, this is where they're encountering, I'm sure they're encountering the thunderstorm at this point. Looking at the data, it appears to me, and this is the common and correct thing to do, is you're going to kick the autopilot off, or the autopilot is going to be kicked off because it cannot hang with this level of turbulence, and the aircrew needs to hand fly the aircraft. If you think this is scary as a passenger, it is terrifying to the crew up in front of the aircraft when this happens and both windshields get smashed to the point to where you can no longer see out of them. One of the first things that happen once you hit the heavy hail is the outer layer of hardened glass on the windshield shatters. These windows are not going to completely collapse and ever cave in on you because they're much too thick. They're made up of 3 layers of very heavy tempered glass. We'll show you more about that structure here in a moment. But the outside layer is designed to crack. Along with the loss of the windshield, you usually have a whole bunch of warning lights going off. The autopilot kicks off. And in this case, it looks as though the ram air turbine or the RAT deployed. There it is, the ram air turbine. The ram air turbine, or RAT, is an emergency generator, and on the Airbus A320, there are a couple of ways the RAT can automatically be deployed. One is the loss of both engines, but what really drives the loss or the dropping of the RAT is the loss of both main AC buses. If you lose both engines, you lose both main AC buses. That's what triggers the RAT to deploy. You can also manually deploy the RAT by flipping this red guarded switch. The RAT will provide you emergency hydraulic power and electrical power, enough of each to fly the aircraft. Even if both engines are out, you'll still have enough electric power and hydraulic power to control the aircraft. In this case, no, the engines didn't flame out, but something caused the RAT to deploy, and I believe it was an intermittent loss of both main AC buses. Now, if the RAT is the only thing powering your electrical system, you're only going to have the captain's set of instruments, and the FO side of the instrument panel is going to be blank in an effort to conserve energy. But I suspect these guys probably got their main AC buses back, but the RAT was still out. Once it's out, it's stuck out. There's nothing you can do about it. And of course, the ram air turbine provides hydraulic power to the blue system on the Airbus parlance, better known as the center system in Boeing aircraft, where most of your hydraulic equipment is located. The RAT is also a constant speed propeller, so it'll continue to provide this emergency electrical power and hydraulic power down to about 120 knots or so of airspeed on the aircraft before the RAT stalls and can no longer provide that power. That is, the propeller of the RAT stalls. By the way, if you're on emergency power with this RAT deployed as your only source of power, the aircraft is in alternate law. Remember that from your Airbus training? I didn't. This is not the first time an airliner has encountered a heavy hail impact event. Here's an American Airlines Airbus A319 back in, June of 2018 with very similar damage. Smashed outer windshield panes and a smashed radome. We'll talk more about the radome in a moment. But I want to get back to the startle factor, why this is so terrifying to air crews. This happens, as you know as a passenger, this happens very suddenly. The hail impacts the windshield goes out, the lights come on, the autopilot kicks off. There's a long moment of massive confusion in the cockpit. What do we do? What just happened? Somebody has to snap out of it. And so now it is a regular part of our training where the first thing that any of us do now during an emergency is make it a declaration of my aircraft. Somebody has to snap out of it and say my aircraft and start hand flying the aircraft. By making that statement, my aircraft, that is an effort to get over this startle complex that one of us has control of the aircraft and we're going to work on a plan to recover this aircraft. This can be so startling that you may have to lean over to your partner and physically touch him and say, John, my aircraft, we're going to divert to here. And then begin to work on your plan. It's extremely startling and you have to get over it pretty quickly. And then once you get over it, training kicks in, it's ops normal, and you just do a normal diversion. But you can't see outside of the windscreen. Now let's talk a little bit about this radome. People see the nose smashed off of the airplane and are shocked by it, but this is what the radome is basically designed to do. The aircraft is built out of aluminum, but the Radome is built out of a dielectric polyurethane foam that allows the weather radar, which is this, here's the receiver antenna located right here, which sweeps back and forth, that allows the weather radar to see through the structure, the dielectric foam, to see through that structure to be able to pick up the weather radar returns from the weather ahead. And of course, once this is destroyed, your weather radar is destroyed. So you're not only flying blind visually, you can't see out the windows, you cannot see the weather ahead any longer either, as your weather radar is busted. A couple other features of the dome are these metal strips you see here on the side, and you'll see those on the outside of a normal dome embedded into the structure. That's to help dissipate static electricity off of the dome so that the weather radar can get a clean picture of the weather ahead. Here is your localizer receiver antenna located down here. And then there's foam and material behind the weather radar to help protect the aircrew from excessive radiation emissions from the weather radar. Outside of the damage to the windscreens and the weather radar, there's usually not a lot of additional damage to the aircraft, as these leading edges of both the engines and the wings and the flying surfaces are pretty darn strong. That hard curved leading edge can handle the hits of the hail pretty well. Now let's take a look at this encounter from a passenger's perspective. Well, you got to keep your seatbelts on. Did you see that? Was that a kid or a passenger? Nearly made it all the way to the ceiling. That's why you got to keep your seatbelts on at all times, tighten them up, and why the idea of carrying an infant with you is not going to work in a lot of these situations. It's going to hit you so suddenly and so surprisingly that you're going to lose control of whatever you're hanging on to in this level of turbulence. Now you can hear the hail impacting the aircraft. Looks like an old episode of The Twilight Zone, huh? Now let's talk a little bit about the pilot's windscreens, the front windscreens, why they're not going to completely fail on you. They're designed and built by PPG, the same folks that provide you your paint down at the auto parts store. And here's the layup for the main windshield of the A320. It's 3 layers of Herculite 2 glass. That's a tempered structural glass structure. 1, 2, 3 layers. The outermost layer is a thin layer. That's designed as a sacrificial layer to be cracked or smashed by hail or birds. And then there's, I'm not sure what this interlayer is right here, but there is layers of air in between these different panes, and the outside layer is also treated with a coating to provide anti-icing for that windshield. And that anti-icing warms up that windshield and also provides it a little bit of flexibility for in the event of bird strikes or hail strikes. But only that thin outside layer is the layer that fails on these windshields during these hail strikes. An interesting factoid I discovered on my research for this video was Herculite was designed originally for hockey. That tempered glass you see at the hockey games, which replaced the old chicken wire fences they used to have up here. So how this crew got into the hailstorm or thunderstorm in the first place will be up for review. It does happen. The weather radar is not foolproof. There are some incredible advances in aviation weather reporting technology and turbulence reporting technology that is coming available to us soon, especially if you have real-time Wi-Fi access into the cockpit. You can add additional layers of safety to avoid these sort of situations. One of the common things that can happen if you're trying to work your way around a line of thunderstorms, the weather radar may only see the front line of thunderstorms. You're trying to find the weakest point in this line of thunderstorms to get through it, But behind that line of thunderstorms may be additional thunderstorms that you cannot see because the weather radar cannot see behind the shadow of the initial line of storms that it is reflecting off of. So good job on behalf of the crew of Latam Airlines Flight 1325 once they encountered this hailstorm, getting this aircraft safely back onto the ground with limited visibility and no weather radar at night. This sort of event is a very shocking event when it first happens to you. Good job getting over that initial shock and getting this aircraft back on the ground safely. Thanks so much for your support of this channel, especially the folks over on Patreon that are making this content possible. See you here.